Hi everyone, and good afternoon, and welcome to this ASHRAE Ireland webinar. We're delighted to welcome Dr. Tom Lawrence, ASHRAE Distinguished Lecturer, to join us today. It's actually a good morning for Tom. He's joining us from Georgia in the USA. My name is Tony O'Keefe, and I'll be chairing today's session. I'm also joined by Daniel Coakley, ASHRAE Ireland President, and Adam O'Donovan. If anything goes wrong, I'm sure they'll pop up on your screen pretty quickly. So just as a general introduction, before I hand over to Tom, so I'll cover a little bit of housekeeping to start with. Tom's going to present on the integration of smart grid and smart buildings. And then at the end, Adam O'Donovan, our Student Activities Chair, is going to join us to present to open the Student Awards. And Tom will announce the winners. The Student Awards are a very important part of ASHRAE Ireland. So just in relation to questions and feedback, if you have any questions, please use the questions tab on the right-hand side of the GoToWebinar panel. It's very straightforward. And by all means, put a hand up, or if there's any questions, or if you want to interject with anything. We'll try and keep the questions to the end. There's a 5 to 10 minute period at the end where we'll cover the questions. And there's also going to be a copy of the presentations in PDF format available on the download section, and there'll be a recording live on YouTube available as well. Just to cover some of the recent technical events and training that we've covered. Since COVID, we've moved all our events to online. The last time Tom was with us was, I think it was in Dublin a few years back.
Yeah,
hopefully
about 3 years ago.
Right?
About 3 years ago, I think it was.
Yeah, we were in the beautiful Engineers Ireland building. I recall you were presenting on high performance buildings. Please God, we'll get back to that fairly soon in any case, and we'll just make do with the online for now. But we have a fairly full schedule of events. Anything that has been recorded is available online on our YouTube, and please do join us for any upcoming events. We also have, in addition to the local training, we have the ASHRAE Learning Institute, and they run a range of courses which are available at the link provided on this slide. So please do have a look at that. So just to give a little introduction, before I hand over to Tom, I suppose Dr. Lawrence is the Mechanical Engineering Program Lead with University of Georgia. He has nearly 40 years of professional experience. He spent the first 18 years in industry, and after going back for his Ph.D. at Purdue, he has been at UGA since 2004. As an ASHRAE Distinguished Lecturer, he gives seminars related to high-performance buildings and other topics at venues around the world. Dr. Lawrence was named an ASHRAE Fellow in 2017 and was a Director at Large on the Board of Directors of ASHRAE from 2016 to 2019. Today's talk is going to be on the integration of the smart grids and smart buildings. A topic that certainly is very relevant at the moment here in Ireland. We recently received stark warnings around potential power outages this winter and for a number of winters ahead of us. So you know, the smartening up, let's say, of the grid is really important, not only for reliability of power but also for the decarbonisation of Ireland and our building stock. So Tom, I will hand over to you. And I'll change broadcaster right now.
Okay. I haven't seen it pop up. Oh, there we go.
Very good.
I guess across the Atlantic, it takes a while for those electrons to swim.
Or else is my poor management on this side.
Okay. I can see it. Yeah, I can see it in there in the background. So let me make this full view and start the slideshow. All right. Good afternoon, everybody. Can you see everything work out well?
Yeah, coming through clear, Tom.
Perfect. Good.
Oh, sorry, it's just changed there now. Your screen's changed.
I see that.
Yeah.
Try it again.
There you go.
Oh, you know what? Well, let me try it. see if it stays on. I hit the arrow to move it off to the side. So anyway, technology works wonders for everybody. So good afternoon, everybody. Happy Friday. Fridays are always good. It's morning for me, but that's okay. You know, Friday morning is good as anything else. So I'm giving a talk today, or talking about this particular topic of, you might think, you know, most of people in ASHRAE members are mechanical engineers. We're talking about something that's, you know, more information technology, but it's a part of a group that I've been involved with for about 10 years now that have brought me into the era of information systems and using informatics, you know, to help go forward. So this is the start of that point. And the idea of, there you go. We'll scroll through a few of the intro slides, you know, all those usual things you do. Course description, because this is actually part of, we have a 3-hour course that I should do on this particular thing. But, you know, talking about how buildings and the smart grid itself, how they be integrated together, and then communication from that. As we see going forward, this is pretty important. Get involved with your local chapter. You know, this is the ASHRAE commercial slide, I guess, I'd like to do. And I have to see, looking at the different speakers you've had, you know, for this session here, for this chapter here, you must have some pretty good connections, because you have a lot of heavy hitters in terms of, you know, ASHRAE presidents or former presidents. You know, but I've really been blessed in terms of the sense of being involved with the distinguished lecture with ASHRAE. You know, you see on the screen right there, all the different places outside the US I've been. And one of the reasons why I show something about that is it took me, you know, 5-6 years ago, I realized, you know, that I've been to a lot of these places. You know, the people look different, they talk different, but we're all solving the same kind of problems. And we're in this together. So this is, I think, an important part. So today, what I want to talk about is, you know, first define what is the smart grid and a smart building, and talk about the challenges to make it together. You know, a key part of having a smart grid is actually meeting, you know, the demand, matching the demand on the grid with how an individual building, or actually, you know, a collection of buildings, how they respond to that. And then some of the other, how smart buildings and smart grid can actually increase the overall resilience of our grid and our society as a whole. And we'll talk about that going there. So first, ask, you know, what is a smart grid? You know, we've all heard the term, we talk about that, you know, but really, when I do my discussions on whatever topic I'm talking about, you know, define what are we really meaning? And really, when we say smart grid, it's a, you know, modernized grid system. But if you go outside and look at, you know, electric wires running around, it still looks the same. The biggest difference is that the electric grid now is using information exchange back and forth between the suppliers, you know, the generators, and also the consumers, and to communicating their status, communicating the needs, maybe reduce the demand, and also in many ways, just, you know, how much is that building is actually being used. A smart meter actually provides information back to the utility for doing building purposes. You know, and we could talk about a smart grid applying to other utilities, you know, natural gas, you know, water, gasoline, where they have smart controls. But, you know, for the purpose of right here, when we say smart grid, we're talking about the electrical grid, which is for buildings there. And then I've had, you know, somebody, at least early on when I started doing this, people would ask, you know, really, why is that important? Why should I care? You know, ASHRAE, if CTTC, whatever, you know, society, you know, it's important because, for one thing, it's here already, it's happening, it's growing. So we need to be involved with that. You know, buildings will be affected by that in the future. You know, we need to provide systems that can interact with that. Buildings, you know, HVAC systems, lighting will be involved with communicating, you know, their energy use, maybe adjusting demand based upon the grid requirements, depends upon the situation. And also really, you know, especially for maybe a younger ASHRAE member, you know, it's a new discipline opening up. You know, it's more than just energy efficiency, it's actually talking about, you know, load management, you're talking about electrical load management. And, you know, the equipment that we're using, that we're specifying, we're including in buildings, is already being converted to adapting to, the idea of a smart building and or smart grid. So it's happening no matter what. So what is needed? What components are put together to make a smart grid? Well, the first part of it is having what we call smart meters. Smart meter is basically what makes it smart is it has the ability to have communication, two-way communication between the utility and maybe the meter itself. I know where I live at, my Georgia Power, which is our electric utility provider, went through about 15 years ago or so and converted all their meters to smart meters. There's a significant investment. The reason why they did that, they now use that as their way of billing purposes. They can monitor what's being, the monthly usage, and they produce the bills from that, as opposed to what used to happen in the past. The people will walk around and look at a meter, write it down, and then that's what your bill came from. So it's really moved beyond that. The two-way communication between utilities and users, individual devices, maybe the buildings themselves, all that, work together. And also, to make that happen, there's obviously there's software packages and that are involved in making that all work together. We need, on buildings, we need the ability to actually maybe receive that signal, and if we're going to act on that within a building, we have to be able to do this. But there's a lot of, it's all information flow back and forth. And so some other parts of this, it's not just the building themselves, but the individual pieces of equipment ultimately could become, connected to the internet and actually directly communicate potentially with the utility and respond to that. It's up to us to make that happen. So how are you going to make this work? You look at this right here. We call it, maybe it's overused term now, the idea of a grand challenge, but to make a smart grid and interacting with that, it's a big investment in terms of things. So traditionally, you look at the darker arrows on there, utilities will generate electricity from some form, fossil plants, renewable sources, going through the grid, goes into the buildings, and within the building itself, you have individual pieces of equipment. You got a pump, maybe electric vehicle charging stations, plugs on their appliances. But the biggest difference right now in terms of the smart grid is, see the dotted lines, that's where information exchange is going back and forth between each of those components there. So utilities, in terms of developing a smart grid, they've done pretty well with that. That's their business. You would expect that. And they've done a pretty good job of integrating renewables into their network. But where the work is really needed is within the things that we as ASHRAE members are involved with, the buildings and building systems and individual pieces of equipment. We're getting there, but we're kind of behind that process there, and I guess that's probably expected. So one thing that we can look at in terms of an overall bigger, longer term vision of how this might lead to is the whole idea or the concept of what we call model predictive control. And 10 years ago or so, when I was, working with, and developing this concept of working with my own little research group within my university, using this idea, and, I knew the term, I knew the idea of the term, but, people hadn't heard of it. It's been interesting to see in the last, few years that more and more, at least within the literature, that are people talking about doing model predictive control. Model predictive control is you have a, for want of a better word now, a digital twin of something, some process. It could be an individual piece of equipment. It could be a building, how it works. It could be my university campus and how that operates there. But in the future, we could see how the idea of model predictive control can be used to determine how the buildings would actually operate in terms of the scheduling, the pieces, an individual equipment working that. It could be the whole building in terms of the schedules, which, from a university campus, some of our lecture rooms are not occupied all the time. So we could actually maybe shut down or go into more unoccupied mode temporarily for that particular campus room. So we can go through this together and build a model to predict how are we going to operate into the future? For my own particular campus too, we're on a real-time price plan. So, we can predict tomorrow based upon the temperatures of the day of what maybe the cooling demand might be, or some cases maybe the heating in the wintertime, and we could schedule our overall system operation to minimize what we think the costs are going to be. Now, ASHRAE has really been hitting forward for this, pretty hard. And, Sheila Haler, when she was president a year or two ago, had made a big push onto having ASHRAE begin to at least be aware of the concept of the smart grid and how we're going to put this together within overall systems. And we created the smart grid application guide. You can actually, it's a free download. You can get that off of the ASHRAE website. And that's really, I think it's been a good concept, to helping us, become aware of that. And so people who want to learn more, and beyond this, just a few minutes of session we're talking about here today, I encourage you to do that. I'll have a few key highlights on that a little later. So some key topics of this, it talks about what maybe you can read the screen right there, how to go through this, there's strategies we can do to enhance the operation of an individual building, so we can basically save money, and we actually encourage, and help the utilities in terms of overall managing their grid through, demand management and things like that. The other things, kind of looking down more toward the bottom, like the concept of microgrids are really, potentially have the ability to work through and help us operate through, disruptions in service or the like, and also adds to the overall resilience of the system. Now, speaking of demand response and management, how will we go about and do this? And so there's different scenarios we can look at. The traditional way that we're doing so, at least what I'm used to, I'm going to assume it's pretty well common across the world. We would think of when we have high demand relative to overall supply. In a situation like where I live at, typically the summertime, you have a lot of cooling that's involved with this, and it's putting a major stress on the grid. Same things will happen in the wintertime when you have, maybe a cold snap, and you have a high winter heating there. All that is increasing demand on the electrical supply, and utilities have to respond to this. Because as a reminder, I had this discussion with my class yesterday on a basic green building course. Electricity is instantaneous in terms of what it is. What we're consuming right now is actually being generated right now, for the most part, until we get to the point where we have a lot of storage built into the grid system, so we can use maybe incorporate more renewables into the supply. So that's a traditional way of going about this. The utilities want to manage that that load. When it goes up, when it's near the peak, everything's operating at 100% capacity or pretty close to that. It puts a strain on the grid, and they're more likely prone to failure and not as efficient. Part B on here, or scenario B, is actually something that's really we've only seen this in the last 10 years or so. In this case right here, we might have, using variable or renewable energy, is actually variable. We cannot control that quite as well. We just can't turn up and turn down how much is being generated. So how do we manage, peak production from distributed and renewable energy generation systems and fit that into the grid? So, the first example we've really seen this has been with Germany. I'm sure you're aware that Germany has made a major effort on converting into renewable systems within their grid. I think June of 2013 was one of the first times that temporarily during a time period, they were generating more in that country than they actually can consume. It was probably a sunny, clear Sunday, but they were generating more. So what are they going to do? How do they manage that? And even parts of the U.S., some parts of the U.S., that is actually becoming common as well. There's a lot of areas where we have wind energy, wind power generated electricity, but it's in a part of the country where you don't have a whole lot of demand. So we have to ship that out therefore. So managing that. So that's it's kind of almost the inverse of B. And then there's also been another looking at in terms of managing this from, minimizing the carbon footprint from electric energy production. So sometimes you might generate more. So we can forecast when, more wind power might be available, say in the UK or so on that, or nearby that, when you want to maximize that. You want to generate as much as you can and perhaps even store that as make it into the future there. So there's different scenarios that we can looking for with this. And also, when we look at a situation, and this is maybe more with solar generated electricity compared to anything else, but and this is a situation that in existence right now, like in the state of California in the US, they are adapting a lot more solar energy to their grid, and they're getting to the point where as the sun starts going lower in the sky, and in evening hours, they still have the same kind of demand, but they're not generating as much from sun. So there's a huge ramp up that has to occur from this point. So it's, they call it the duck curve. You kind of see it from the duck shaped wings from that. And is another problem that has to be managed in terms of within the grid. And this is looking at putting a case forward for doing demand response management for not just for industry or commercial buildings, but maybe even residential going forward. So we're looking at, we're seeing, at least in the US, and I would suspect that could be around there, is that, we're looking at not just the entire network, maybe the entire country of Ireland, but you're actually looking at the local situation with that, managing from a local basis there. So addressing demand response upon the local areas of what we're doing for. And then it points out the need for potentially for having maybe energy storage in buildings in parallel with utility scale storage. So an individual building can maybe act as a battery to kind of help and feed in within the local part of the grid. So that's all that will allow the utilities to operate on a smoother basis and kind of avoid some of the situations that we can do. So this is kind of basically respond to that point. Interesting that down at the bottom right here, looking at the concept of what we actually termed as reverse demand response. And if we get to the situation where we have a higher percentage of renewables into the grid, at some time periods, other areas of the world might be like Germany is. We might want to increase the demand and the load to avoid wasting it. So you could do, maybe charging up a battery, or I've even heard of the potential terms of, and making it free to have your electric water heater run for a while, or charge up your electric vehicle car, at that point for free, perhaps. It depends on how this works. If you have excess, and make that going forward. So I want to talk about now, and within buildings, how do we do demand response? And going about this. So first, I would go through and just talk very briefly about a couple of situations in terms of requirements or encouraging for doing this. So within the US particularly, we use the LEED program for basic green buildings, and they actually have a credit for adapting and having the capability of doing demand response programs. So you actually participating in that, you can get a couple of points, and at least having the capability of doing so. Because when you within a building, if you're going to do demand response, sometimes that might be automated. You have to set up so you can actually go through and do this. Within the International Green Construction Code, which is based upon the ASHRAE Standard 189.1, having that as required. You basically have to have the capability within your building control systems to go through and do this. And some ways you can go about that. Look at maybe adjusting the HVAC set points. Bring them up in the cooling season, bring them down in the heating season, and have the capability of doing so. A few other things. If you have a VFD on a supplier, an air handling unit, maybe setting that to a maximum of 90% instead of 100%. So it's operating not quite as high as had to do. In some cases, you can actually make some adjustments to the lighting. Studies have shown that you can, if you have a dimmable lighting type system and you slowly bring that down, you can do it somewhere in the 10 to 15%, and people don't notice. And that temporarily could go through and make an adjustment. These are all the things that can be done. We have to look at ways of adapting that, and ideally do these things without people even noticing it. So if we're going to, maybe design a new building or working with an owner, talking about how we're going to implement maybe demand response, first thing, decide, what is possible for this particular building. In a new building design, it's easier. You can build that into the specifications and say, this is what we want to overall control systems. An existing building, it's a little more difficult, because a lot of it is a function of the building controls, and they're very expensive to replace and go through and talk about that. So, buildings typically contain some what we call deferrable loads and non-deferrable loads. Deferrable is something, we can curtail that at least temporarily. Some things we have to keep going, for security purposes, for safety, for whatever. So the question is asked, if you're working with a building owner or talking about the overall design, what could we possibly curtail? How long can we do it? The utilities sometimes want to know, they might want verification that you actually are doing this, particularly if you're signing up for participating in a demand response. And who does that verification? We also look at, the thermal comfort considerations for the occupants. I mean, you can change temperature set points to an extent, but after a while, when people start noticing it and they start complaining, that becomes a problem. And then, obviously, we're looking at safety and security, and then, making sure that we are in control of this process and it doesn't get out of hand. Now, also looking at doing a demand response, excuse me, there's two different, sorry, there's two different scenarios we could have from that. One, we could say externally generated. Say the utility is in a peak demand period, they ask you as a building to curtail certain amount, 10%, or there may be a certain amount of agreement you're going for. So they are generating that by the utility provider. It could be also, internally generated, and that's maybe a response for that. Now, when I say by that is like, again, my university want a real-time price. We know 2 hours in advance what the price of electricity is going to be. So we will initiate our own demand response to eliminate demand, because we want to limit, the overall cost impact that's going to be for us. And that's really, in some ways, you might say that's being generated by the utility because they're setting the price. Go for it. Okay, that's how that works out. So we looked at this in our own campus of what could we possibly do in terms of existing campus facilities and limiting the overall peak. So we set up a test scenario. The first year looking at this was several years ago. It was on a Saturday because the facility management did not want to impact the occupants within the particular building. So you can see from here we changed the zone supply temperature or zone set point temperatures and the supplier temperatures. We put a limit on the ones that we could in terms of the like air handling unit fan speeds. And then also when we did this and implemented that and tested that, then we also did a thermal comfort survey. Did people even notice it? And we did this on a facility, part of the campus. It was in a chilled water distribution network, and just took 2 of the main buildings. You kind of see this by picture right there on the campus. So it's only 2 buildings out of 200 buildings total of that, but you just want to see what the load could be. And you see from this right here, this is just the chilled water supply for one of the particular buildings, and the green arrow or green line on there, is projected was typical for that particular building at that particular time of year, what we'd expect in terms of the overall cooling load for that particular building. And the blue line is the measurement of actually what was being supplied. So, the difference between that's what was the savings, and it was fairly significant at that point. Now, one thing we did this particular test was we implemented and started this at 1 o'clock in the afternoon, and at 5 o'clock went back to normal. And so you kind of see this big bounce back, the rebound effect. How do we avoid that? In fact, looking at the peak, if we were trying to do this in terms of reducing the peak demand on electricity consumption, we didn't affect that any. In fact, we had worse because it was actually going through and trying to recover from all that time period when we had higher temperature set point for cooling in this particular building. Had a lot of exposed stone and the hard surfaces right there. The interesting thing with this is that we did some students going around doing survey at the same time as going on, and thermal comfort survey. And during the test day, it was pretty good. We had this. If you people are familiar with the predictive mean vote or the percentage of people dissatisfied, it wasn't that bad compared to the next week. We did another survey, but at the same time, and in the same buildings, and it was a little bit higher, but not that bad right there. The next year, we also looked at doing this not on a Saturday, but actually during the time periods when we had classes in session. And so we look at incorporating the same type of scenario, same type of situation. We also looked at within this, because of the chilled water distribution loop, and you can do the same thing from hot water, banking of cold. So we actually pre-cooled the chilled water before the afternoon set in, bringing it down a little bit of cooler temperature, and then letting it ramp up during that peak period right there. So breaking this down, looking at this point right here, we were able to save about 11% of the total energy consumption, and also about 11% of the peak demand from there. And all this, we did thermal comfort surveys in the same time there. Nobody noticed, nobody cared, nobody died. So it was seeing the demonstrations what that could be. So some lessons learned we got from that. Some of the set points, could be altered, maybe even making higher than what we did. But you have to think about this for this kind of situation, and maybe it depends on the type of building we're looking at. What's the optimal set point changes? When do we start that? When do we stop? And how to avoid that rebound effect. You saw that the previous slide a couple times, the bounce back, that actually was even higher peak than would have been before. So we need to kind of implement, for want of a better word, the soft start in terms of the overall systems. We're familiar with soft start motors. Well, really, in some cases right here, talking about the building systems, especially if you're talking about HVAC, soft start on that as well. One of the more difficult aspects of this is that, especially if we're talking about an existing building, the technology may not be in place to do this. And so the control systems have to be set up so you can actually do that point. And how you implement that when we don't have a higher level automated, in terms of a building control system, it's more difficult. Manually you could do this, and somebody could sit there and program and make some changes. It would work, but that's not really cost effective overall. Now, looking forward about how a smart grid would increase the overall resilience of the built environment, and this we're going to talk about each one of these a little bit more. But another topic that I actually give some talks on is the concept of resilience within building systems, and how all these other factors we've been talking about for several years: sustainability, efficiency within the building operations, and smart buildings and smart grids. If you think about this, all of those together help increase the overall resilience of the built environment, of the individual buildings, the systems that we have, the whole society structure there. They all interact and help increase those and make them work together. Oops. So looking at within building systems, we've seen over the years, the evolution there. We developed the ability to connect all of our control systems, all of our pieces of equipment within the building operation, the HVAC systems and lighting and all that. We can automate that point. And then as we evolve this and gone further, the capability optimizing that, minimizing the energy consumption, still providing what's needed. And then actually even the top of the pyramid on here, fault detection and diagnostics. We're seeing more and more equipment that are coming around that have the ability to automate, and diagnose a problem, or even detect when it might be occurring and send a signal out and say, hey, this particular part might fail sometime soon. And we're looking at in terms of how we would connect, a building to a smart grid. That building energy management system is most likely like the way to be interacting within the utility for connecting within a smart grid for doing things like demand response. And Chuck Gollins, when he was ASHRAE president during the pandemic year, one of his main themes was the idea of having, smart buildings and working within the grid, increasing the efficiency of how we design buildings, how we interact with them, and we're, moving beyond what he called the analog age into the digital age. And looking at new technology for doing overall design, virtual reality, and walking through, and maybe you're probably aware or seeing the capabilities we have with some of the new design software, actually doing virtual walkthrough on buildings there. So I would encourage you there. If you haven't seen Chuck's presentation, even though he's not president now, it was really inspiring. I think that we're working from. So we're talking about smart buildings now, and this whole idea of, smart whatever 4.0, my observation, this is my summary of what we do and how we get the smart buildings 4.0, which was the theme what Chuck talked about. 1.0, hey, it's hot, it's the cooling season, open up a window. 2.0, oh, we got air conditioning, cool. 3.0, we had, building automation systems, BACnet, whatever, in that time frame. But now we're getting into the idea we have, open ADRs, open automated demand response, and the ability to, a building to automatically respond to that. We have digital twins of a building operation, digital twins of individual pieces of equipment. We got the Internet of Things. Everything's interconnected between us. So all we have is information to exchange back and forth, and that's really what we're talking about here in today's session, is to look at that. So also leading to that is that an individual building, smart building can interact with the grid, but also it could have, a collection of buildings. And so, good candidates for that might be for a microgrid, might be, a university complex, like myself. We actually operate our own grid. We have one interconnect point with our utility and work from there. Or, a large corporate campus or a medical complex, military bases are another way of working together. And that's a great way of managing. Basically, your own little small your grid itself, and you can work from that. Maybe you can generate some power for your source, potentially even operate as isolated from the overall grid itself. So one way of going about this, maybe having combined heat and power systems, you're actually generating some electricity through, maybe natural gas or whatever that's fed into a generating unit, and then using some of that excess heat for maybe generating cold water, for using cooling purposes, or using that heat for heating within the building. And all of these are right here are talking about the overall increasing resilience within the electrical grid, and actually within society as a whole, of how we withstand, some extreme events, floods or earthquakes or snow and ice or hurricanes, what I would use for. Part of working forward in terms of this is that if we were going to implement and use a high amount of renewable energy within the grid, we need to store that. So storage is going to be important with this, and buildings will be asked to do part of this. Building integrated storage as much as well the utility size. But there are some challenges of this in terms of energy storage. First, it needs to be cost effective. It has to be reliable. the utility is not going to want to adapt that unless they can't count on this. We also have, in some cases, at least I'm aware within the U.S., the regulatory environment in terms of allowing storage to be counted into the overall capability they have that. So some of that storage could be embedded in the building systems we have and overall design. And we as the building designers might be asked of this. So also you look at, if we have enough energy storage, we even need to negate demand for demand response. Well, possibly. I mean, potentially that's so. I would propose that we need to do both going forward from that point. Having an emphasis on resilience within an individual building or as within a city or nationwide scale is important, and having energy storage will lead to that, and provide a lot of this. And another benefit that we have from a smart grid can improve our recovery from major weather events. I'm showing you pictures right here. That's the back of my house. We had the remnants of Tropical Storm Irma, 4 years ago or so, went through, and that was the same storm that knocked out the power grid in Puerto Rico for several months. I'm showing this right here is that our local utilities basically said that they were able to increase the recover from the electrical grid about two or 3 days faster than they would have, because after that storm went through, about 70% of the customers in the state of Georgia were without power for a while. Now, I kept power, but I lost my beloved fig tree that got blown over from right there. But that's showing how that the smart grid with all the smart meters, they knew exactly which customers had power, which ones were not. So now we're going to kind of talk about, so how are we going to evolve from here? So we, have the smart grid. I hate to use the term, the 1.0. We have some connectivity from that point. We're evolving into the next step from this. More of a connected environment, more automation, more building systems are able to work with this. But people are speculating, how it's going to evolve into the future. We're basically now buildings are connected at that point. Individual pieces of equipment are connected. Everything belongs to that smart grid. So we can have, AI-based evaluation of what's going on and be able to predict and work from this point. We have self-healing, self-learning systems. We could have, if you have a building that has a potentially for generating some of its own energy, electricity, moving forward from that point and saying, all right, we had, a transformer just blew out over here, and we're going to help out with the grid by, generating excess power and feeding into that point. So increasing the distributed electrical generation by buildings adds to the problems of the utilities in terms of the managing all that, but also that increases the overall resilience within the system. We're not having everything being generated in small packages in, say, power plants located around, but we're spreading that around. So with the future, where are we going? Some proposal by the National Renewable Energy Lab here in the U.S. has talked about, more of an autonomous electrical grid. Basically, it's self-aware, knowing when things are going on, be able to adapt and adjust the load, or perhaps even feed excess into the grid to help maintain the overall supply about this. Another, question that's come up, and I'm not sure within Ireland that how that's been brought up, and in the U.S., and at least in certain areas, there's a movement to basically require or move towards basically all electric in terms of facilities, basically minimizing or alternatives to, say, things like natural gas. Natural gas is a relatively clean fuel, but it still adds to the carbon footprint. As we have more renewables in the electrical grid, we're trying to transition and working towards that. And this is very contentious in terms of, within the politics we have date, as you might imagine. And I'm not sure if that is going to catch speed going forward, but it's something to think about this. So why would do that? Again, actually the city of Berkeley has banned natural gas hookups. Some other cities are considering that, but also am surprised that it's pretty controversial. My own particular state, being a more conservative at that point, has banned cities from even considering this from that point. But there's an alternative of doing this. We can actually take renewable energy and generate hydrogen, electrolysis. And I think there's an experiment going on right now. I think it was put in place in Scotland. I think it was talking about using excess power or using power from wind farm out in the North Sea to generate electricity, use that electricity to convert and make hydrogen from the water, and then feed that hydrogen into the natural gas lines. So it's reducing the overall carbon intensity for that point. One thing without that, I know I'm gonna make sure I keep track of time when going through it. The smart grid is really opens us up potentially to, basically a cybersecurity problem. There was a famous example here in the US a couple years ago where a company was hacked into through a thermostat, I think it was, so they actually were able to tap into that thermostat and tap into the network, and then they use that to go into the overall system. So it is an important consideration looking forward. So what do we as building designers need to consider? Now we go back into thinking about this point. We, or overall, the building design, look at things like, are we going to design for on-site renewal? Are we going to have PV systems, right? Are we going to have distributed generation, maybe combined heat and power systems? We're going to have more advanced building automation working forward. Electric vehicle charging stations may be included in that as well. That, I can really see in the coming years, or that just becomes part of an overall design of say a new building. That's part of what we do. And then back to the more simpler part of it, our HVAC systems, and looking in terms of the ability to do the demand response. And everything I've talked about up to now is talked about more of a technology aspect of this. But really, we have to keep back in mind, the human factors. Human factors are important. Human beings are the ones that might be impacted by set point changes in HVAC. Human beings are the ones that actually maintain these systems right here. So going around now into the future with a laptop is what may be maintenance on a lot of the systems there. And it's much more complicated than we would do. All right, I am done with this. I tried to pretty well keep it on track time-wise. I hope I was good for that. I see how we want to address in terms of any other questions.
Tom, that was excellent. Thank you so much. There was, I suppose, a lot of the points were quite relevant to us, despite the fact you were touching on the States and so on. I've one question coming through here. Do you have any knowledge of the EU development of a supergrid as a means to cope with the intermittent nature of some sustainable generation?
Well, yeah, and I think that first of all, I'm gonna, when we stop sharing my screen, maybe that was it right there. So yeah, there you go. So back, the idea of the supergrids, kind of what I was referring to here before, and in the sense of everything working together and communicating and be able to handle in terms of the overall resilience, or also making it from the sense of managing, even to use additional resource, making sure that we're not wasting renewable energy that's being generated, like the situation like within Germany. Sometimes they generate more than they actually can consume. And other situations, trying to managing if you have a major power outage someplace due to an unforeseen event, and then be able to feed that together. So this whole idea of the smart grid from a larger perspective, managing what's going on is really important there. So I think what you just described is kind of core of everything what I was talking about before. And the way you make that happen, one of the ways to make that happen is the ability to communicate back and forth between the utility, the buildings, the industry, transportation network, and all that interacting and working together. I believe that is a way to address that, and that overall is a good thing. Now, for like Ireland itself, I mean, you know, I don't think you're connected in with say the rest of the England or Scotland or anything like that. So you're basically operating. I'm sorry.
We have a UK connection, all right, but it's relatively small for the amount of, I suppose, the amount of generation that we potentially have. I think it's mainly an import supply, but there is talk of a French connection.
No, yeah, I think, you know, right now you're operating, you know, for want of a better word, as an island, and that's more that actually brings out the importance of the ability to manage within your own individual country by yourself. Now, if you have an interconnect with, you know, France or England, and that might be looked at as maybe as an emergency backup kind of thing, and potentially in some situations you might be able to feed back the other way if it's needed. Yeah.
We actually have a lot of renewable generation in Ireland, a lot of potential for wind generation, not only in the existing generation capacity, but also in I suppose planning, I suppose other wind farms held up in planning and so on. But and we also have that, as you mentioned, that growing demand for electrical consumption with, you know, electric vehicles,
Right.
the move to heat pumps for heat generation. You know, it's mainly, I suppose, heating demand we'd have in Ireland as opposed to cooling, and we also have industry. We have a lot of data centers here, and that's become quite controversial. Right. That you know, that we should be, you know, turning away that industry as opposed to facilitating it. But we also, with our existing buildings, I feel we have a lot of potential in our commercial building stock for demand response, demand management, that kind of short-term reduction in power consumption, especially in motive power. We have lots of buildings with BMS systems, energy management systems, that could be changed over, that could be, I suppose, upgraded for demand response. But I think right in the middle of it is that grid. And without the, I suppose, the financial benefits and the direction from the grid being able to cope with it, and I suppose instructing the industry to respond, I think that's the key point. And is that similar for yourselves?
Well, and what you just described probably can be echoed in pretty much every developed country around the world. I mean, the U.S. is the same way. You know, we have a lot of potential. We're talking about, you know, developing a lot of offshore wind. You know, the Biden administration just a couple of days ago, you know, announced plans for doing a major, you know, investment in doing offshore wind, so we can generate even a lot more. And your particular situation, you know, tying into not just Ireland itself, but, you know, tying in within the rest of the EU and UK, you know, that gives you the capability to feed back and forth. And you can imagine, you can almost think of Ireland as a building or as an entity, and interacting within the larger picture grid. You know, I think you use the term super grid. You know, that's the future, and automation gives us the capability of doing that now.
Okay. Tom, I'm going to move on now. So thank you so much for your time, and you might stay with us. I'm going to bring in Adam O'Donovan, who's going to introduce the student awards. Adam, are you available there?
I am, yeah. Thanks, guys. Thanks for the talk. It's very interesting. It'd be very, very relevant to some of the sustainable energy engineering students in MTU Cork, anyway, to be sure, one of which is with us today. Thank you all for being here. I'm Adam O'Donovan. I'm the Student Activities Chair for ASHRAE Ireland. I'm also a postdoctoral researcher in MTU Cork campus, which was a CIT NI3 Tralee. It's now MTU. So you'll be hearing this from now on. I suppose in the context of Ireland, there's 35 members on an annualized basis, and this usually kind of ends up being 3 active student branches, one in MTU Cork, one in Galway, one in UCD. And I suppose the difference between us and other chapters is that we support our students with free membership. So every student gets free membership, which is sponsored through in this case, our sponsors, which would be Daikin and Google this particular year, and Daikin have funded for numerous years before this, and Google have come on board recently. So this year, we're also expanding this to allow our students to get handbook online access. And so this is another way of us supporting our students in this specific area. The reason why we're here today is the student, the actual, the awards themselves, and the awards were started in 2018 when we wanted to kind of, I suppose, acknowledge some of our students in our different universities that have student branches, and allocate an award to the best student. At the time, it was undergraduates and masters. Today, we actually have a PhD awardee, so it's expanding wings. In actual fact, we have an undergraduate, a masters, and a PhD today, which is great. We're getting the full spread. We started in 2018, and we're up in Dublin in the IBIPSA ASHRAE symposium, which we tend to hold every 2 years. But obviously with COVID, that changed recently. But and David Underwood was there at the time in Trinity College, and we were giving out handbooks. They were very very lucrative at the time, and a nominee is awarded by the student branch advisor for each student branch. And from last year in particular, from 2020 to 2019, that direction, we had a virtual event, and we now offer 3 years of membership through Smart Start. So we fund the Smart Start for these students. So in terms of we've members outside of Cork, Dublin, and Galway. We've also got members in IT Sligo and people across the country. But today is about these 3 awardees, and I might hand over to Tom to announce the 3 of them.
All right, so we have the first one in terms of Paulo. I hope I pronounced that right. And looking at his particular topic there, residential energy management control system. This is really an open area, I think, in terms of what we have. We have a lot of commercial buildings, but looking at residential is really a good way of going about this. So, it looks like Paul is graduated and moved on, is actually now a research associated or looking pretty close to that. And so congratulations for that. And I really think the idea of having the Smart Start sponsorship is a good thing. I haven't heard of anybody in terms of student awards doing that. So I want to give a good shout out to you all for doing that. And next we have Alexander, a nice picture there with his graduation there. We're looking at faith-based materials for doing demand response. That fits right into the topic that we talked about here today. So, looking at the master's degrees, actually working, looks now in the States there. I don't know if Alexander is on. I can't see all the attendees. Hopefully he is, and he's doing early morning just like me. And then next we have Aaron Mansfield. Congratulations for the point. Now we're looking at the thermal model of electric vehicle cabin. I actually couldn't relate to this because I had a PhD student graduate a couple of years, and she went to work for NIO, I think is how you pronounce it, the Chinese electric vehicle startup. And basically her response or her research was on thermal comforts, and so it was really related to that point. So I could identify with this one quite as well. And think about an electric vehicle, how you get heating in there, it has to be electric. You don't have a motor generating waste heat that you can use for heating purposes, and it's all electricity. I have a plug-in hybrid, and so I'm totally aware of how it works as well. So congratulations, Aaron. So.
Well, then, thanks so much, Tom, for that.
Thanks, Tom.
I'm just going to close up with a few messages here now. I suppose I'm going to skip through mainly because we're quite tight on time. I just want to mainly say thanks to our sponsors, and in particular, thank you, Tom, for your time today. It was fantastic. It was really enjoyable, and hopefully you'll be joining us soon in person for another lecture.
I look forward to that.
Hopefully it'll be soon and we can enjoy Guinness at that time.
That's right.
Thanks, Tom. Bye now.
All right. Cheers.